Good morning to everybody. My name is
Morning.
Grzegorz Siewierec from Institute of Soil Science and Plant Cultivation. We warmly welcome you to the Nations Project thematic event on soil decontamination. We still let you to enter to the event, to this online event. We will start presentations and the workshop in 1 minute. Okay, I think we can fully start. So welcome again. Warm greetings from our side, IUNG. We welcome you with our nation's project partners supporting us today, Trust IT and Polimi. So this event is being recorded. You've been informed about that. You can always use chat for comments and questions to our presenters today. And there will be online polls launched during this event. You are very welcome to take part in these polls. They will be open at the first question and answer slot. So this is the thematic event, the European-wide digital sessions dedicated to specific topics important for the nation's project and the whole soil mission. And there were 6 events, thematic events, covering a wide range of topics important in terms of soil management. And this is the last event dedicated to industrial, post-industrial areas, especially soil remediation, soil decontamination. So, and the goal of that series of meetings is to present state of the art, the challenges to be overcome, and share best practices, share experiences. In our case, on the topic of soil decontamination, to inspire innovative approaches for future living labs, which are in the center of soil mission, facilitate, encourage cross-country collaboration, cluster stakeholder groups, all that to stimulate development and involvement in living labs dedicated to healthy soil. So we try to encourage networking, collaboration on a transnational scale, and someone help to enlarge the process of application to soil mission calls, especially those dedicated to living labs. This is the agenda of today's meeting. We've got wonderful speakers today. So this is divided into 2 parts. One is on the state of the art, referring to metal contaminated soils and sites, to organic pollutants. And then we've got a session dedicated to implementation of soil remediation. So there will be some experiences from at regional level, from Saxony in Germany. There will be Iceland soil mission project showed. There will be good practice examples from from Poland, from the remediation site in Silesia regions. There will be approach of living labs for soil remediation present. The overall goal of Nations Project is to facilitate deployment of a soil mission, especially to support establishment of living labs dedicated to soil. And this is the range of tools we deliver within Nations Project to facilitate this through engagement events, thematic events like today, fact sheets, help desk, coaching session, webinars, and matchmaking platform. This is the link to matchmaking platform. Feel free to use it if you have not registered yet. Okay, so and the entire goal of soil mission is to establish at least 100 living labs and lighthouses across Europe, and mission is implemented through four major components: funding, research, and innovation, establishing network of 100 living labs and lighthouses, improving, developing a harmonized framework for soil monitoring, and what is very important is raising society's awareness on the importance of soils and the need to protect the soils. And one of the objectives of the whole mission is to reduce soil pollution and enhance restoration of soils. That's why we meet today during this thematic event on soil decontamination. Okay, thank you for that was a short introduction to the event. Now I would ask Eugenio to to present the Miro board too.
Yes, thanks, Gregors, for the introduction. And yeah, as we said, like one of our main scope of this thematic events of Nation is to also enable some networking among participants. In the room now, we have 139 people. Some of you, while registering, they also share their expertise and willing to participate in the next calls. So we prepare this digital board that you can access through our chat. You have the link, and there you can start navigating and having a look who else is in the room today. So it will be like a sort of a background working space where you can start keeping touch and establish some contacts with other participants. So that's the main scope. So feel free to comment, to take notes, to take the contacts of other people. That's the main idea. So beside this networking, you will also find again the links to the matchmaking platform. So we warmly invite you also at the end of this event to register to the matchmaking platform, which is a sort of a very lively animated a platform where you can also establish more contacts and participate to matchmaking sessions while the calls are open soon. Okay, thanks, Gregors. This is just a short introduction to the Miro board. Your mic is off, Gregor, so probably.
Oh, sorry. Okay, thank you, Eugenio, for this information. So it's time to go to the first presenter. So I would like to invite Markus Puschenreiter, representing University of Natural Resources and Life Sciences in Vienna. The floor is yours. Thank you.
Thank you, Grzegorz. Good morning, everyone. I'm happy to start this workshop with the first presentation, where I would like to give an overview on plant-based soil remediation options, phytoremediation options, aiming to decontaminate, remediate metal polluted soils. And I would like to highlight some success stories, but also mention some research gaps that we still are facing and that are needed to address in order to bring this technology forward to practical application. In principle, we can divide soil decontamination options into two different major approaches. On the one hand, technical solutions represented by this picture on the left. But in the last decades, several plant-based gentle remediation options were also developed, and some of them are already working very well, but for some, there are still some limitations, and where further research is needed to foster the further development and bringing these options ready for practical application. Briefly, what are the main phytoremediation options? I would like to focus on two of the options shown here on this slide. On the one hand, on phytoextraction, where the pollutants are accumulating in the above ground biomass of plants, and phytostabilization options, where pollutants are immobilized in the soil with the help of plant activities, but also supported by the help of soil amendments. In the case of phytostabilization, the pollutants remain in the soil, but the bioavailability is strongly reduced, whereas in the phytoextraction option, the pollutants are removed from the contaminated site. The research work on phytoextraction probably started with this plant species. It's one of the so-called metal hyperaccumulating plants. Nochea caelescens, a plant that grows in Central and Southern Europe on metal-rich soils. This plant is able to accumulate several percent of zinc in the above ground biomass. Also cadmium and lead is sometimes accumulated, and therefore it was identified as one of the candidates that could be used to decontaminate soils by phytoextraction. In the last decades, a lot of metal hyperaccumulating plants were identified. You can see here an overview on plant species that are able to accumulate different metals, as shown on the very left, in the above ground biomass. Maybe also to get an impression what hyperaccumulation threshold has been identified, so which metal concentrations can be found in these plants. This is shown in this column, where you can see that, for example, for zinc or for manganese, more than 1% in the dry biomass of plants is these are the accumulation levels that can be achieved or even exceeded. And if you look at the number of plant species that were identified to accumulate these metals, you can see that the majority of plants is able to accumulate nickel. But there are also several plant species that are able to accumulate zinc, cadmium, or lead. So one of the major contaminants that we typically find on polluted soils. There are also some extreme examples where extremely high metal concentrations were achieved. This is, for example, a nickel accumulating tree that occurs on the island of New Caledonia. And here, probably the highest metal concentration was found in a living plant tissue. Up to 25% of nickel was found in the bark sap. And the green color that you can see in this liquid, this is deriving from the high nickel concentration. And already 40 years ago, it was introduced as a first idea that these plants might be suitable to decontaminate metal polluted soils. To start with, I would like to present the prerequisites for successful phytoextraction. Phytoextraction, as I explained before, is aiming at decontaminating soils by using metal accumulating plants. What does it need to make this approach successful? You need, on the one hand, a plant that is able to accumulate the plants, that is tolerant to the accumulated plants, that is accumulating the plants in the above ground biomass. So accumulation in roots is not sufficient. It needs active translocation from roots to the shoot biomass, which can then be harvested on a regular basis. For the concerning the harvested biomass, several treatment options have already been tested, including incineration options or gasification methods. You could also use the plants for biofuel production, and you can also use the plant ash for recovering the metals. I will introduce this approach a few minutes later. If you use metal accumulating plants, hyper accumulating plants, the approach is called continuous phytoextraction, because the metal uptake in the shoot biomass and the shoot biomass production is going in hand until the plants are harvested. Maybe to start with the first success story, I would like to introduce a plant species that was discovered in China. You see here one of the first field experiments where this plant has been applied. Sedum plumbicingicola, a plant species that is able to accumulate zinc and cadmium in its above ground biomass. In this field experiment, where this plant species was grown on a rice arable soil, on an arable soil that was used for rice production, which was slightly polluted by cadmium and which had a slightly acidic soil pH. This plant was grown for 2 years. You can see here the shoot cadmium levels that were achieved and the shoot biomass production that was achieved, resulting in a substantial removal of cadmium from the field, expressed here as gram per hectare. And what you can see here, that within these 2 years of plant cultivation, the soil contamination level was reduced from 0.6 to 0.2. This means in China, the cadmium threshold concentration level is 0.3. So this means 2 years of phytoextraction were sufficient to deliver a soil that contains cadmium in a concentration level that is below the national threshold concentration. So the cadmium removal efficiency was more than 30% per year. Interestingly, the bioavailability was even more strongly reduced compared to the total cadmium concentration on the soil, which is displayed on the left. The grain cadmium concentration in rice grain was even reduced by 85%. So from both perspectives concerning the decontamination in soil and the bioavailability of cadmium in soil, it was a successful application of phytoextraction. Another plant species that is very promising concerning soil decontamination is a fern called Pteris vittata. You see here some pictures in the top that shows how the plant looks like, and it also shows some application example. If you look at the table below, you can see here that at least in the study that I'm presenting here, a sufficient arsenic accumulation level was achieved along with sufficient biomass production, resulting in a decontamination efficiency to achieve the target level within approximately 5 to 10 years. Maybe a not very successful application was done with 2 other plant species, the one that I presented already in the very beginning, and another plant species, Arabidopsis halleri, that is also occurring in Central Europe. In this case, the biomass was too low to achieve a sufficient phytoextraction efficiency. Metal concentrations in the plant biomass were sufficiently high, but the limiting factor in this case was the very low biomass. And in this figure, you can see that both the biomass, but also the concentration expressed here as the bioconcentration factor, are the 2 main factors that have to be achieved in order to achieve a sufficient remediation time. It is probably not of interest to achieve or to establish a technology that would need several decades of decontamination. It's probably the target to achieve a sufficient decontamination, reaching the remediation target within, let's say, 5 to 10 years, or preferably even in a lower time period. On top of hyper-accumulating plant species, in some instances, also metal-accumulating trees were applied, in particular fast-growing metal-accumulating trees like salix or poplar species. The accumulation levels are, in many cases, a bit lower compared to hyper-accumulating plants, but this is overcompensated by the very fast growth and by the very sufficient biomass production. And another success story where these trees were applied is coming from Sweden. Here you can see the reduction of soil cadmium levels after only a few years of salix cultivation. And you can see that with every year of salix cultivation, the cadmium concentration could be substantially decreased. Another approach to enhance the phytoremediation efficiency was developed on the basis of applying metal solubilizing compounds. In this case, the approach is then called chelate-assisted phytoextraction. It is based on the use of conventional high biomass crop plants like maize, where the application of metal chelating compounds should support or boost the phytoextraction in plants that otherwise would not accumulate metals. And you can see that some of these metal complexing compounds were very efficient in increasing the metal uptake levels in plants. But there's a strong limitation concerning the application of this technology in the field. Some of these compounds, like EDTA, which was very successful in terms of enhancing the phytoremediation efficiency, but the problem is it may persist in soil for several months. What you see here in this figure is the leaching of copper after application of EDTA, and you can see that for several months the copper leaching levels were very high, were too high, and may pose the risk of groundwater contamination. So it seems that this application has some severe limitations concerning secondary pollution, for example, of the groundwater. Therefore, several attempts were started to look for gentle boosters that are sufficient to enhance metal uptake per plants, but at the same time have less environmental risk. And it seems that, for example, elemental sulfur could be one option to enhance metal uptake by plants. How does it work? The oxidation of elemental sulfur would, on the one hand, contribute to a reduction of pH in soil, which is leading to desorption of metals and enhancing the bioavailability at the same time. Under some circumstances, it could also lead to reductive dissolution of metal-containing soil minerals like manganese oxides. So in this case, co-dissolution of soil minerals and associated metals would further contribute to the enhanced metal uptake by the plants. At this time point, it is also important to ask ourselves what should be the target of soil remediation. So far, I presented two different targets. On the one hand, a reduction of total metal concentrations, but as you could maybe remember concerning the example where the rice field was remediated, also the question, what is the change of bioavailability in soil expressed in that case as cadmium concentrations levels in the subsequent rice crop. The approach to remove the bioavailable fraction mainly has been called bioavailable contaminant stripping. And there are several examples that show that reducing the bioavailability is very efficient and goes faster than reducing the total concentration levels. But the question is it a sustainable approach? So does it remain on a low level after the remediation period has been terminated? Yeah, another example where cadmium concentration was successfully reduced also in the subsequent crop. I think we are running in time periods, time constraints, so I'm trying to speed up the presentation. Very briefly, another success story is related to the recovery of metals from harvested plant biomass, which is called phytomining. From a technological point of view, it's like phytoextraction, but the main target is not to decontaminate the soil, but to obtain a metal product at the end from the harvested plant biomass, which could also be applied to phytoextraction plants. Very briefly, another success story is related to the application of phytostabilization approaches where metals are, where the metal pollutants are not removed, but mainly remain in the soil, but with a strong reduction of bioavailability, which leads to reduced metal uptake by plants, but has also some wider benefits that are concerned to reduced surface runoff, to reduced erosion, to reduced metal leaching, mainly because a very rich plant cover, a dense plant cover can be established as a consequence of reducing bioavailability and reducing metal toxicity to plants. Very briefly, a few success stories where this approach has been applied to mine tailings. One example here from Spain, where copper mine tailings were successfully treated by this technology, and the plant vegetation cover could be established on a site that was previously free of plants. Another example from Poland, very similar. You see the application of plants and of soil amendments has led to an establishment of a very dense plant cover. And as I explained before, it is mainly based on reducing the bioavailability of metals in plants. The pollutant total concentration level remains the same, but the environmental relevance is strongly reduced. Just a few seconds concerning recent developments. Application of nanoparticles has been addressed as a novel approach to enhance the phytoremediation efficiency, either by enhancing the bioavailability of pollutants or by promoting plant growth as a result of nanoparticle application. Genetic engineering of plants is probably another approach that could enhance the efficiency of phytoremediation. But yeah, success stories in this context are rather limited so far. So maybe it's the biodiversity of metal accumulating plants that is the key at the moment. And finally, instead of phytoremediation, maybe we should switch the general approach to phytomanagement, which is considered as a kind of sustainable overall site management that is not only aiming at reducing the pollutant concentration or reducing the bioavailability of pollutants, but there are wider benefits that may include economic benefits by, for example, recovery of the land value, environmental benefits like carbon sequestration, and social benefits by changing the appearance of the contaminated land. Thanks for your attention.
Thank you, Marcus, for that great overview. I would like to remind the audience that you can ask questions to speakers today by the chat. We just reached 150 participants of this event. We are very happy of that. So now I would ask our next speaker, Jose Julio Ortega Calvo from SIC in Sevilla.
Sorry, I just have problems to stop sharing the screen. How did it happen? Okay, just a second. Yes.
Okay, thank you. So Jose Julio, are you ready to share your presentation?
Yes, good morning, everyone. I am going to check that how it works. It's working?
Yes.
Yes.
It's working. Okay. Good morning, everyone. This is Jose Julio Ortega from Seville, Spain. It's my pleasure to participate in this nation's meeting. Thank you, Gregor, for this invitation. And the focus in my talk will continue the previous talk, but now I will focus on organic pollution, organic pollutants. And the thing is to connect the concept of bioavailability of these pollutants with the soil remediation. So we have to face as scientists that we are in one part of the aspect of the soil remediation overall scene, where we can also have to look at maybe the possible connections to policy regulations and also financial aspects of soil remediation. So we have to face that all our investment may have another aspects that can be treated by other aspects. So the idea of soil remediation with organic pollutants, we propose that the bioavailability concept has something to say in improving sustainable remediation. Indeed, if you look at the different pollution sources, like, for example, in this recent inventory of the Food and Agriculture Organization that we adapted in this book, where they have 1 million of potentially polluted sites can be affected by different sources. The size of this box may be representing the different type of sources that can pollute our soils in Europe, incoming industrial agriculture, urban developments, mineries, and military activities that unfortunately are more active than before. The thing is that if you look at the representative pollutants, many of them have a relevant bioavailability phase. So hydrocarbons, trace elements, you have seen in the previous talk how important is that for soil remediation, PCBs, pHs, or are really having a relevant bioavailability concept that can be applied in addition to total concentrations, which is not giving today the total full picture of the risk of pollution, which is improved by the bioavailability concept. Even if you look at this recent report of this FAO, where they make an assessment at a global scale, the first word in the glossary just is bioavailability. So defining that, and although they don't explain really how well to use it, but this is just to tell you how important is that for the assessment of pollution. So we were aware about that some time ago, and then we made this communication exercise with different stakeholders that was published in Environmental Science and Technology on organic chemicals. So the thousands of papers, of studies during the last 20, 30 years had not found the right way in regulation, in general, retrospective, even prospective regulation, including also retrospective risk assessment of soil pollution. So the challenge was significant, because we can be in the scientific arena that we want to understand the world. This is where we are, where the different definitions, methods are all valid as long as they allow us to understand the world. But talking to regulators, then we have to face the reality that these are people needing to make decisions, assign responsibility, what is polluted, what is not, and therefore there is some need to simplify as much as is possible, but the bioavailability concept for use in regulation. So in this paper, we made this proposal of this use of bioavailability, and then going into the scientific background, we made a sort of review of the state of the art, where we may understand bioavailability mainly as in ecotoxicological context, as composed of different different bioavailability processes that were defined by Ehlers and Luthi, that may involve the exchange of the pollutant with the soil sediment, with the surrounding water phase, the transport of the released pollutant to the biological membrane, or even the direct uptake of the pollutant into the biological membrane, and then therefore later on going on with different biological responses that can be of all the wide variety of biodiversity can offer. Later on, there was a useful differentiation by Kirk Semple and collaborators between bioavailability and bioaccessibility, incorporating the time dependence of bioavailability. So this was useful really to differentiate these two aspects, especially with biodegradation, bioremediation. Bioaccessibility context is an interesting approach, and was the base of a method, of ISO method, for determining bioavailability based on desorption and extraction. I will come back to that later on. And also was another school of thought where the bioaccessibility and chemical activity was differentiated, incorporating the equilibrium approach into the chemical activity approach. That is the base of passive sampling methods to determine bioavailability. Just to tell you that this is a full set of scientific knowledge ready to be used in regulation. The different approaches are all valid depending on the situation and the model you are studying. So the thing is that this was really ready to be used in regulation. But we needed to make some simplifications. So the proposal we made was to differentiate the different bioavailable fractions in such a way that you can provide this measurement for assessment purposes. This was well received by the ISO method published in 2020 to measure the bioavailability through desorption extraction, including TINAX and cyclodextrin. So you can consider with a reasonable degree of certainty that the bioavailable concentration can be determined in a polluted soil after 20 hours of extraction with TINAX or cyclodextrin that extract the rapidly desorbing fraction and what is released into the water phase. Of course, you can also use equilibrium sampling approaches like passive sampling, which is not fully standardized, but they are really strong efforts to make round rings essays, and these are already available in the literature. Okay, so this was already ready to be used in regulation. So when going into remediation, especially if you go to bioremediation, and then you can see this situation. For example, as you have seen before with metals, biological treatments can be very efficient in reducing the risk of pollutants. This is not the total concentration, this is risk. But sometimes, in some situations, you may face an initial increase of risk due to the biological processing of the pollutants. Later on, this is decreasing the risk, and then we can find an endpoint situation where the risk may or may not be acceptable according to the legislation. So the approach is really try to improve this situation where different engineering components can be used from the biological side to have this different approach. For example, there is no reason, no bioavailability, no viable approach to increase bioavailability in these initial situations. So you have to find another approach. My group has therefore looked at the different bioavailability concepts from a bioremediation perspective. So what microbes can offer in terms of reducing the risk by operating on bioavailability on these different processes. For example, you can modify the bioavailability of the release chemical on this part of the bioavailability scenario by not mobilizing the pollutants, but mobilizing the microbial communities, the microorganisms that can be attracted by chemotaxis, for example, through chemical ingredients. And then we have made a research line in my group on this approach. You can also increase bioavailability by attachment, where the attached microorganisms can directly access to the pollutant. And of course, maybe the most known process is you can solubilize the pollutants if they are hydrophobic with the help of biosurfactants. With all these engineering components, we can have tools to improve bioremediation in these high carbon and flow and low carbon flow scenarios. Therefore, let's give you a couple of examples of how we could improve this bioremediation by reducing the risk. For example, in high carbon flow scenarios. So make no sense to add biosurfactants in this because even you can increase the risk. No? So the idea is really try to reduce the risk during the simultaneous biological processing. And in this study that we published in Stoten last year, we could see that this risk, for example, from biological processing could be reduced by adding a sorbent to the system, like biochar, where we added C14 labeled pyrin to the system. This was sunflowers cultivated in sand in greenhouse. And you could see, therefore, that the biodegradation of pyrin producing water-soluble metabolites by the plant or by added bacteria could be really prevented this risk into the leaching by the presence of this biochar phase. So this was one approach of reducing the risk for biological processing by modulating the bioavailability of the pollutants and metabolites. Another situation is in this low carbon flow. So really, is it possible really to go down in this residual level? There is another approach is to improve the risk assessment through bioavailability measurements. But the idea was really to have an action on biodegradation, trying to really reduce these residual fractions below the legal standards. In this way, we published a paper in Stoten with the creosote polluted soil full of PEHs, polycyclic aromatic hydrocarbons, measuring biodegradation with time during the development of the sunflower cycle, and measuring bioavailability during the treatment with this ISO method of Tenax extraction. Later on, we applied some slurry experiments as I will show now. So these are the results in which you can see the disappearance of the high molecular weight polycyclic aromatic hydrocarbons, including benzoate, pyrin, fluorantine, etc., where you can see, therefore, that during the sunflower cycle, there was a disappearance of the pHs, but well, was not really significantly higher than in the controls without plants. At this stage, we added biosurfactants to enhance biodegradation when the sunflower cycle had been finished, and when measuring the bioavailability through Tenax extraction during 20 hours, we could see, therefore, that biodegradation was followed by a decrease in bioavailability in both scenarios, but adding the biosurfactant. And with plants, we could see an increase, a significant increase in bioavailability of the pHs. This increase was not followed by enhanced biodegradation in greenhouse conditions, but probably due to the ecological constraints in these situations. But we studied slurry phase bioremediation with these soils, with these soil samples, and very clearly finding that the increase in bioavailability caused by biosurfactants and enhanced by the plants resulted in lower residual pH levels, as you can see here, from the initial concentration of benzoate in 4 milligrams per kilogram. This was significantly reduced. This was only happening in the presence of the plants. So the plant resource fair apparently was having a development of microbial population that maybe by producing biofilms. Yes?
Because I'm sorry, but we have to finish in 1 minute maximum.
No problem. And these are the conclusions. So hope that we have only 1 minute for conclusions. So just to tell you that we have a slow pollutant phase exchange this is a big impact on bioavailability, but we can modify that with microbial actions and plant actions. Very clearly, bioavailability concept has strength that improves the risk assessment realistically, and then we can incorporate that into these bioremediation scenarios. So just to finish, these are my collaborators. I didn't do most of this work. So some PhDs, some postdocs contributed. And just to finish, to invite everyone into the CTAC Europe meeting that we have this May in Seville. So all are invited. So it still is possible to submit the contributions. And well, I hope to see you this year in Seville. Thank you very much.
Thank you, Jose Julio. I'm sorry I was out of the meeting for a moment, I think. We are a bit late in the agenda, so maybe we would. I haven't seen any urgent questions in the chat, so we might leave potentially the question to first two speakers to the end of the meeting. Now we would go to the poll because and we prepared 5 questions to participants of the meeting. We want to collect some information from you. So I would share the first question. Since I do not see the poll, I would ask my partner Anita Daniel to help with the questions and presenting the results of each question.
Yes, thanks, Gregor. So the first question to all of you is, do you have experience in soil decontamination, soil remediation? Yes, of course, the first answer, soil contaminated with metals. Yes, soil contaminated with organic contaminants. And yes, contaminated with emerging pollutants, or no. So please take your time to answer, just to have a sense of who is in the room, how familiar you are with the topics that we presented today. I think this might help also to know better. Okay, maybe
few more seconds.
Few more seconds, yes.
To the end of the poll.
Yes, so results say that among the participants, we are about 150 people in the room. 42% say no, so they don't have any experience with contaminated soil, so they are new probably to the topics, or they don't have a direct experience. While the rest say that they are, let's say, they have experience on the decontamination, with 32% with soil contaminated with metals, another 21% with soil contaminated with organic contaminants, and only 5% with soils contaminated with emerging pollutants. So this is the results of the expertise we have also in the room on soil contamination. And then next question, second question, what type of experience do you have? So it refers more to your background. So it's in terms of research, advisory, as landowner, technology provider, financing, legal, none of them. So this is more about your role on the topic of soil decontamination. Let's wait some more seconds. Of course, that's an easy question.
We expect to have some people from the world of academia and research, but also some advisory or technology providers. Landowners, of course, are also more than welcome to share their experience with us.
Yeah, also, if you had a look to the Miro board, we have this mix of representative. And yeah, of course, it's similar to what we have in our digital board. So 63% of people here are involved in research and academia. And then we have a 6% advisory, 2% are landowners, and then we have a 4% of technology providers and 6% of legal in the legal sector. So, but we have 19% of people that they say they are none of them. Maybe it would be nice to know where do you position yourself? Maybe you can say to us in the chat so that we also know that there are other types of expertise skills that might be involved in this soil mission. Okay, and then we go to the next question, the third one. What is the most challenging in soil decontamination? So it might be financial problems, legal barriers, insufficient knowledge or technology transfer, awareness, stakeholder engagement, and lack of innovation. So what do you think is most challenging? We heard from the presentations that we have several challenges, of course, technical, but also governance challenges, societal challenges. So this question is very interesting to also know from your perspective.
Of course, always feel free to write in the chat if you find or have a direct experience of challenging situations in your field and in your field of expertise.
Okay, I think we can see then the results. Let's see if they are quite distributed. Okay, so interesting, 38%. So it's the highest percentage goes to financial problems. Second option, 23% goes to insufficient knowledge and technology transfer. And then we have a good 14% on awareness, and followed by stakeholder engagement with 10%. And then legal barriers and lack of innovations reach up to 7%. So it's a good variety and distribution of the answers. So it's interesting to know about that. Yes, thanks. Also in the chat, we have some other comments. Yeah, and then the fourth question for you is, what project partners would you look for? You can also have multiple choices here. So are you looking for scientists, advisors, financing bodies, regulators, industry, and landowners? This is very important also considering the next calls that will be open soon in spring. And so we also aim to establish consortia. So it's interesting to know where we are, let's say, directing our efforts in networking and matchmaking. So considering that we have a lot of researchers and academia here, probably the answers will be more on like finding other type of expertise, but let's see. So take some more minutes, seconds for answering. Okay. So what partners are you looking for? answers say that, okay, so it means that even if we have a lot of representatives from academia and research, nevertheless, the participants here are looking, 60% are looking for scientists, 37% are looking for financing bodies, and I forgot, 47% for industrial partners. And then followed by regulators with 24% and landowners 27%. And in the last position we have with 10% advisors. Yes, thank you. So we have also an overview of what potential partners are looking for. So the sixth question is, what type of innovations are needed? And of course, it's another multiple choice answer, so you can indicate more than one answer. And if you want to complement the list here, which is of course limited because of time constraints, you can also add it to the chat. So okay, which innovations? Nature-based solutions, innovations in monitoring and soil testing, or analysis of ecosystem services, remote sensing, plant biomass treatment, machine learning and artificial intelligence, or cost-benefit analysis. So which innovations do you think are mostly needed also for advancing on this topic of soil decontamination? If you don't find any, I mean, the answer you're looking for, you please, you could add it in the chat. Let's wait a few more seconds. Okay. So let's see what are the answers. So they are also quite well distributed, but there is a clear predominance of nature-based solutions with 65%, followed by plant biomass treatment with 38%. So nature in general. And oh no, we have a second position is actually with 55% innovations in monitoring and soil testing. So technology is also relevant. Then third position, I already said plant biomass treatment. Then we have in fourth position, 36% answered analysis of ecosystem services. And then we have, cost benefit analysis, almost the same, 37%. Of course, that's very important. And then we have remote sensing technologies with 17%. And the last one is, for now, machine learning and AI, which is probably an emerging topic and will be more popular maybe in the future. Okay, thanks. Thanks for your contributions to these polls.
Thank you. Many thanks to the participants. That was really interesting. And thank you, Anita and Eugenio, for leading this. So now it's time to go to the next speaker. That will be Ingo Miller from Saxon State Office of Environment, Agriculture and Geology. Are you ready, Ingo?
Okay, if you ask me, I thought that Finland would come first, but of course, if you say I should start, I will do. Okay, I will share my screen now. So I hope you see now my presentation.
Yes, we do.
Okay, great. So welcome to my more or less general presentation on contaminated sites management in Saxony. I'm Ingo Müller from the Saxon State Office for Environment, Agriculture and Geology. working on soil contamination and remediation already for some decades. Saxony is one of the German member states in the southeast, so sharing border to Poland and the Czech Republic. Okay. Let me first introduce some of the more or less legal definitions in Germany, which are more or less relevant for managing contaminated sites from assessment to remediation. There are in general two different kinds of contaminated sites. One are the former industrial sites or dump sites, often labeled as point source sites, and all the other contaminated sites, usually large areas of elevated pollutant concentration. On the other hand, well, the first ones very often have an impact on water, groundwater, or surface water bodies. The second one have usually an impact on direct human ingestion, usually by children playing on the soil, something like that, or dust inhalation, and agricultural land with contaminants transfer into food or fodder crops. And this all together posing risks for individuals or the general public, let's say for environment and ecosystems. So what are the general aspects of contaminated brownfield management here in Saxony and Germany in general? So it needs an initial suspicion that there is a risk on a site. Usually it is due to the site use, the former site use, the industrial branch working on the site, dumped materials, or handling specific contaminants on the sites. In Germany, action is always based on risk or hazard for the targets that could be humans, plants, animals, water bodies, or air via a specific pollutant linkage, soil to human, direct ingestion, or soil to plant transfer, or soil to groundwater, etc. Measures have in Germany always have to be adequate and proportionate. That's quite important because not everything what could work in outside in the field is an option to be implemented in remediation, because often it says that the mildest often goes along hand in hand with the cheapest option for a reasonable remediation is chosen. So the regulation builds the framework for every action. That means that every case, every single case, every decision has to stay within the regulative framework. As we heard just in the poll before, there could be some constraints regarding regulation. So we have official and stepwise decision and action procedures laid down in the regulations. And usually assessment starts following the pollutant linkage, the affected targets, and the specific site use scenarios laid down in that regulations, coming from very sensitive site use like playgrounds or housing areas to parks and leisure areas or industrial sites, farmland, grassland, something like that. So that's just a table to show you what the formal steps of contaminated brownfield management are here in Germany or in Saxony. And the first ones you can see are done by authorities. So usually it starts with the authority, which has to go to do the first review. It's more or less a formal process to put that site into your database, phrasing the suspicion of contaminants according to the site use, as I mentioned before, and looking for the history of the site, a second step, what has been done before at the site, what was the site use over decades, and what is the suspicion of contaminant concentration in the site, and also the distribution of contaminants in the soil. And then it starts with taking soil samples. The preliminary assessment means that you have to check if there's a first idea of all your suspicion could come true. You say, okay, it could be contaminated, and then you analyze samples, and then you say, okay, yes, it could be, or no, I'm wrong, I was wrong as authority, and then this it will stop here. Otherwise, next step will go ahead with a detailed assessment, and then it starts with the responsibility of the site owner or the site user, of course, under administrative supervision. But now it's clear that it's not, more or less, not the job of the authorities anymore, but the job of the site owner or site user, if there is any to be blamed. And then it goes ahead if the detailed assessment says already, yes, there is a risk, there is a contamination, then it goes ahead with a survey of remediation options, option appraisal. What are the best options for the site, from decontamination, sealing, encapsulation, or safeguarding measures, and then looking for remediation itself. How could the technical remediation procedure could be applied at the single site? And of course, monitoring and control. Does everything works and runs smoothly as we expected? Now let's look at the quantity of maybe suspected contaminated brownfields in Saxony in last year. It's the data from December. Evident industrial or commercial sites. Most of the sites, about 30,000 sites in Saxony already, and former dump site or waste disposal sites, 7.7 thousands, and military and armament sites, about 400 sites. And if you look, one site could also be split up in different fragmented parts, let's say split up by a road or by a river, something like that. And then you can see that more or less 21,000 sites in Saxony we have to deal with, and about 30,000 fragmented parts of the sites. So what was done, the status of this, let's say, about 21,000 sites in Saxony? You can see that there's an amount of 18% where the assessment is done, but there was no risk. Then we have 33% of the sites where the assessment is done, and there's actually no risk at the current land use. Let's say if it stays an industrial site, everything's fine. But if you switch the current land use, let's say to a housing area or building up their playgrounds, something like that, or kindergarten or schools, then there would be a risk, but there's no need of direct action. Then we have 34% of the sites where the risk assessment is still to be completed. Its work is on the way. We are working on the sites, but it is not ready to say, okay, there is a risk or not, or there is the risk so high so that we have a need for remediation. Only about 1.5% of the sites were finally, nowadays, the risk is finally confirmed and there is a need for remediation. And you can see 13% have already fulfilled that circle. That means the remediation is done and was successful. So over years, you can see that there is a progress. The green bars are rising. That is the suspected parts of sites where the work is finally done is rising, and the sites where the work is still to be done is going downwards. So, okay, you can see a progress, but you can see that it is working very slowly. It's not a fast-growing field, so can you see it's a more or less like work in progress. And yes, you know, all of you know, if you're coming from brownfield management, that it takes time. It takes time for assessment, and it takes also time for the remediation. So what are the general aspects for the next larger problems we are facing here in Germany? It's the large area contamination in Saxony. So what we have done is we intensely conducted a geochemical survey as a basis for information. And we found mainly naturally elevated concentration of trace elements, specific metals, due to the bedrock and mineralization. So it's natural. And you can see here a map of Saxony, where you can see that we're around 40,000 samples we took from natural soils. That means no brownfields, no industrial sites, no places close to roads or mining sites, tailings, something like that. That were natural sites, and we are looking for, let's say, more or less the natural situation On metals, as you can see on the next slide, 3 maps for the main contaminants we are facing here in Saxony, which is arsenic, lead, and cadmium. And you can see in the south of Saxony the yellow and red areas, which mean elevated concentration in natural soils, especially for arsenic and cadmium, but also for lead. So we have to face that we have large area contaminated areas, and to do an assessment for that areas due to elevated metal concentration, and they are labeled for us like ticks, meaning trace element contaminated sites, naturally contaminated or polluted sites. And this one were inserted into regional planning procedures because we have to think how it could work, living there, do farming in that region, something like that. So we did a special detailed assessment for that areas and defined so-called soil planning areas here in Saxony. It's a specific legal instrument. That means all you can see here at the map in yellow are identified areas, which is more than 2,000 square kilometers of soil, which is highly contaminated with arsenic, lead, and cadmium, exceeding all the legal definitions for exceeding the risks, meaning direct ingestion for children living there, or for food and fodder production on arable land. And then we implemented some of that soil planning areas to deal with that soil sites, that regions, and to manage risk at that regions. And what there will be done, I will show you on the next slide. So what are the general aspects of managing the large area contamination? Usually the risk assessment is using pollutant linkage scenarios, which means that there's mainly the problem of soil ingestion by humans and soil to plant transfer here, not soil to groundwater. It's not, the metals are fixed to soil, and that they are not going downwards to the groundwater. So we use trigger values to judge the risk according to the German regulation, and then followed by a special detailed assessment using statistical data on the bioaccessible fraction of metals in soil and survey data on metal transfer into crops. So we define concentration levels where different levels of action are needed here in that for that regions. So we have in the next step, final step, a special implementation of categorized measures according to a statistical likelihood of exceeding levels of action, meaning that we have a regulation of managing transfer and reuse of excavated soil. It's a living region. A lot of people are living there. Roads were constructed, buildings were built up. So we have a lot of excavated soil and have to know what to do with that soil. So there is a specific regulation for that areas. And we have an implementation of safeguarding and also remediation measures according to the land use scenarios, meaning that we have a specific scenario for playgrounds. And if specific concentrations are exceeded, there is a need for remediation, meaning in that general, the sites are very small. We go for the classic quick and dirty solution, dig and dump. And some others are more or less only slightly polluted. There could be safeguarding measures like a small layer of wood chips on the soils of the playgrounds, something like that. And on the other hand, we have recommendations for the farmers, how to use soil in a region with elevated concentration of metals. And of course, the remediation is to analyze food and fodder products prior to placing them on the market. It's only a recommendation because food and fodder products are already under close mesh administrative survey due to EU regulations, you know that, and it's the same in Germany. So the farmers are told how it could work, meaning controlling pH of the soil and looking for specific crops, variants or species. What could be implemented, or if it will not work, they should switch to biomass production instead.
Ingo?
Yes, it's the final slide.
Perfect, thank you.
Okay, so let me wrap up. Managing contamination in Saxony, there are more or less two different situations. We have to look at the contaminated brownfields with the main pollutant linkage into water. Remediation means often hotspot decontamination, sealing, pump and treat, and other water remediation options. The polluter pays principle usually does not work, to be honest. Therefore, also site owners or users are called to account. Often, finally, administrative bodies become responsible if no one is left to be able to pay for that. And it's for that only mainly an administrative development regime for that sites. And on the other hand, the large area contamination, the main pollutant linkage is human ingestion and the soil to plant transfer. We have prior ranking, risk management, and recommendations installed over there. And decontamination or soil cover layer for sensitive use, like playgrounds, is already installed. And we have therefore specific aid programs for financial supporting to overcome the situations here in that regions. Okay, and that's it for today. Thank you for your attention.
Thank you, Ingo. Wonderful. Indeed, I mixed the order of presenters. Sorry for this. Sorry, Marianne. Sorry, Ingo. I want to, before I give the floor to Marianne, I want to say that it is possible that 2 or 3 meeting participants can present yourself as partners at the end of the meeting. Very brief presentations, 1 minute. So if you wish, some of you, please write this in the chat. So now
yes, we are already collecting the candidates. There is also one question in the chat. I don't know if you want to address it now or later.
We can address it now. This is the question about the terms used by Jose Julio and also Inigo. What is the difference between bioavailability and bioaccessibility? So who of you want to briefly respond?
Okay, I will start first. In Germany, we have 2 different situations. That means bioavailability is often used if contaminants are so readily available in soil that they could really easily be transferred into plants or leached downwards with the seepage water. So that's bioavailability. It's a different kind of extraction procedure laid down in the legal framework here in Germany, as well as the bioaccessibility, which means what is at least accessible by human ingestion, meaning going down to the stomach and going down to the colon and leaving the body, and what really could be taken up by human ingestion. That's the definition here in Germany, but it could also be put other around. So I'm just keen on hearing Jose's information on that.
Thank you. Thank you for this question, because it has been the center of many of the problems of not using this in regulation, the communication part. So, I mean, I like to make this overview in my slide and just to show maybe one of the reasons of not being used more often. This general scientific background is this type of terminologies. So I try to escape from that myself and always talk about bioavailability, because then you explain what you do and what you measure, and there's not a problem. So both are, my opinion, my humble opinion, in terms of organic chemicals, because it's the chemistry behind is different depending on whether you talk of trace elements or even if you talk of organic chemicals. The developments in the organic environmental chemistry, environmental organic chemistry, have been a bit more recent. And in terms of bioavailability measurements, we have really good tools. Whether you measure equilibrium concentration through passive sampling or a bioaccessible fraction by TENAX, then you get a measure of risk that improves the picture in addition to total concentration, which is today not fully enough to have a realistic risk assessment. So both are valid, and you can find many different definitions of bioavailability, bioaccessibility, and they are all right. In terms of, if you look at the ISO method, you talk about bioavailability, and then you talk about bioavailable fraction, but to somebody may mean bioaccessibility. Doesn't matter. It's a fraction of the total pollutant that is giving you the risk. That's it.
Thank you. Thank you. Jose Julio is a lecturer, so he could speak about bioaccessibility for 1 hour at least.
Sure,
Thank you.
more.
Even
Thank you.
more. Thank you. Now I would like to ask Marianne Valkama from Geological Survey of Finland. Please present Iceland project. Thank you.
Yes, can you see my screen now?
Yes.
Okay, good. So yes, hello, my name is Marianne Valkama. I'm from Geological Survey of Finland, GTK, and I'm here to present our project, Information-Based Strategies for Land Remediation, abbreviated ISLANDER. And I will present the project at a general level and then say a few words about our stakeholders and stakeholder activities. So let's start with basic information. So this is a multidisciplinary project aimed at supporting the execution of the EU mission Soil Deal for Europe, as well as the European Green Deal objectives. The project received funding through the Horizon Europe program, and it was officially launched on the 1st of May 2023 with a foreseen duration of 3 years. So this is our first working year coming to an end soon. Islander brings together 14 partners from 13 countries, including 10 EU member states. And Geological Survey of Finland, GTK, acts as a coordinator of the project. So let's look at the project's objectives more closely. I mentioned the supporting of the EU soil mission, and more specifically, the Icelanders' research activities are designed to provide tools and methods so as to support one, the delineation of polluted soils across Europe. 2, an evidence-based assessment of the risks posed by polluted soils. 3, the promotion of sustainable and risk-based land management practices. 4, the inclusion of a wider valuation approach in financial and investment cases. And 5, a closer integration of land contamination and spatial planning decision making. And finally, the lessons learned and experience gained throughout the project will be used to number 6, which is to deliver key policy relevant findings related to the soil mission and soil strategy, and especially related to the proposed directive on soil monitoring and resilience, as well as other areas of policies where soils are crucial. Just shortly, the key outcomes that we are expecting to have at the end of the project. So Icelander will provide USO, which is a European Soil Observatory, a user-compatible metadata catalog, and a roadmap to data on soil contamination in Europe. We're also going to create a risk-based SPR conceptual models, as well as financial and spatial planning models. And the project will also provide a decision support tool and a roadmap, and they are focused on low input techniques on soil remediation. In addition, we are creating a strategy for sites and a policy paper, and these are for guidance and support, so to say. And yeah, now let's take a look of how the work is actually done in the project. So to reach these objectives and outcomes I just described, we have 6 interactive work packages that are presented here in this chart. And as you see, they work interactively with each other, but as well as with our clients, or I would rather say stakeholders, as well as our test areas, island test areas called ITAs, which I will describe soon more closely. But first, I will tell you something about our work packages. So first, number 1, VP1 is data-oriented and will evolve reaching out to a pan-European member state soil databases in order to capture a relevant picture of soil contamination. And this includes hotspot areas, and both in urban and rural areas. Work package 2 is dedicated to the assessment of risks associated with degraded soils, and it proposes to further develop advanced source pathway receptor models within risk assessment approaches in contaminated soil management to better assist in the identification of contaminants of emerging concern. That needs to be considered as a priority, but also to better integrate large-scale risk assessment and soil health and related to soil functionality in the risk assessment. Then work package 3 will address the feasibility of specific sustainable remediation technologies, and they are selected for their efficiency, reliance on biological and or nature-based processes, as well as economic feasibility. And then work package 4 aims to develop financial models for decontamination and reusing of land that can effectively support investment cases for private and public actors. Moving on to work package 5, which aims to develop optimal strategies for the prioritization of soil remediation in Europe, in urban and rural areas, as well as the promotion of sustainable decontamination and reuse. And finally, work package 6 supports finalizing the decision support framework and soil strategies via feedback to from other VPs and by engaging stakeholders to provide their views and ideas for the project. And VP6 also aims to ensure the broad adaptability of the project outcomes. In addition to these interactive packages, we also have 7, 8, and 9, which are related to management, communication, dissemination, exploitation, and ethics, and they run throughout the project. And on the right side, there are the ITAs. You can see them on the map, and let's talk about them a bit more. So, the principal aim of these island test areas will be to road test the project's findings. And as illustrated on the map, 7 ITA areas across Europe have been identified. They are located in Finland, Sweden, Poland, Netherlands, France, Kosovo, and Cyprus. And to begin with, the ITAs will provide a real-world context for the planned research activities. And more concretely, they have been selected to cover different land use types, such as urban, peri-urban, rural, agroforestry, mining, wetlands, and coastal areas. And furthermore, the ITAs are characterized by both point and diffuse sources of pollution, as well as by different soil pollution types. And then there is the interaction with the clients or the stakeholders. So Islander takes a targeted approach in existing knowledge base and has designed its outcomes to be easily assimilated by multiple target groups, including policy interests, planners and regulators, site managers and their service providers. And support for capacity building is ensured, as well as service to the needs of long-term repositories, most importantly, EU Soil Observatory, EUSO. One of the key focuses of the Islander is also to facilitate the soil remediation even when the case is economically marginal or negative, by providing a more thorough understanding of low input approaches and wider value proportion for investment cases and financial planning. And that is why the left behind areas are mentioned in the client's sector. Okay. And so, yeah, let's just continue with the stakeholders. So key actors, stakeholders, and end beneficiaries are at the epicenter of Islander. And engaging stakeholders to provide their views and ideas for the project is an important step in creating the Islanders' objectives. So the stakeholder activities include, for example, questionnaires and roundtables at the ITA areas. And through these roundtables in the respective ITAs, the foremost assignment of local actors will be to provide feedback and offer insight as to the robustness and effectiveness of the strategies, frameworks, and decision support tools, as well as on the wider valuation approaches and financing mechanisms to be developed over the course of the project's lifetime. So thus, the roundtables are foreseen to bring an like iterative feedback loop to the research process with a view to ensure the wider uptake of the project's outcomes and achievements.
Marianne, 1 minute left.
Oh, yeah. So, and as an example, on June, we are arranging a stakeholder event in Finland's ITA area, Outokumpu, which is a former mining area, where the project members and local actors and, for example, Islanders technical board members will attend to discuss and have an excursion on our ITA area, which is a former mining area. I only have a few slides and I will go them very quickly. So other important stakeholders for Islander are our technical advisory board, shown here. And very importantly, a common forum and the EU Soil Mission Board and EUSO are represented, as they support our objectives as key stakeholders related to the goal of the project. And we also have been having a cooperation with other projects and platforms and engagements, but I think I'm running out of time. So So thank you for your attention, and please do not hesitate to contact me if you have further questions.
Thank you, Marianne. Many thanks for this presentation of your project. I would like to ask all participants to mute yourselves. We could hear a dog participating in our meeting. Thank you. So I do not see any urgent questions to Marianne, so I would like to ask the next speaker, Tomasz Stuczyński from our institute. The floor is yours.
Oh, thank you, Grzegorz. Thank you for giving this opportunity within the framework of this exciting project. What I'm going to speak, let me start sharing our presentation.
We still see
okay,
the
I
screen of
cannot stop.
Marianne.
I cannot start sharing, Marianne. You would need to end sharing, and then yes, thank you very much. Now I can do it. Yes. Yeah, let me. Okay, so I will target an efficient, maybe not quick, but an efficient sharing. And I think it will be much easier because of all the excellent theoretical background and sharing experiences, but previous speakers. So that makes me really happy, and it's indeed helpful. So I'm going to speak today about a project, remediation project, which we implemented starting in 2018, starting from a proper site assessment, following all the legal framework in Poland. I don't want to speak about details because it's a topic by itself. The site is nearby Katowice, southern Poland, with rather a long history of industry. And this is former Hajduki chemical plant, which has been heavily contaminated. You can see this marked as a black kind of rectangular. And operation started back in mid 19th century. So it was tar distillery, then it went through different types of investment and evolved into benzene, toluene, paints production, as well as producing naphthalene, anthracene, carbolic acid. So you can imagine that at that time in history, there was no environmental protection measures, no particular management schemes. There was a lot of leakage. And this particular site concerns railway siding and kind of trail siding, where engines stopped and all the cisterns with leaking valves. And as we learned, after over 150 years of operation and demolishment of the facility, we found more or less 20 tons of naphthalene equivalent remained in the soil. And excavation was not possible because you, as you see, it's also an area with different facilities. It's close nearby residential neighborhoods that would not be approved. And of course, we went through a formal risk and health assessment, and it turned out that even though it seemed not to be the most efficient, we got approval for phytoremediation as kind of a compromise between what should be done and what can be done, also cost-wise. This is a bit historical background. That is how it looked like over 100 years ago. You can see some spills, that some dark spots. And when we made boreholes and then took surface samples, the highest concentration of pHs and other petroleum hydrocarbons were found along these tracks, which is not surprising because, as I already mentioned, there were leakages from these cisterns. And at top layer, basically there was some soil formation process, but basically the top layer was covered with mine spoil, was underlaid with some medium clay. There was no continuous groundwater horizon. So therefore, underground aquifers were not endangered, but there were other risks, of course. And fugitive dust unrestricted access to this area. The initial levels quite high, but these are just in the surface layer. But if we go deeper, they went into some extreme numbers, like anthracene can be as high. In some spots, we found like 1,000 milligrams per kilogram of soil. Even more. So authorities agrees to bring it down as long as the air quality around and health risk is reduced. So what we come with was an idea to do everything in situ without removing any soil, and we adopted special remediation pile by moving contaminated soil and piling it to clean up sites for building construction, as the city wanted to construct a waste recycling, for like bottles, plastics, and stuff like this. So we decided to establish this remediation pile, amend this with compost to create some rich organic matter rich top layer with sufficient microbial activities, but to make it easier for poplar hybrid to grow, we also made some drilling, like holes drilled up to 4 meters filled with clean soil to create some type of suction, some type of drainage, and using hybrid poplar roots to pump up contaminated water up to a root zone where it could be decomposed by bacteria. So this is a theoretical. Jose presented kind of similar public domain process principles. So we have both phytodegradation here, rhizofiltration. Basically, these poplar trees work as a pump. And this is how the layout look like. So all the green areas around, this is the soil material piled around, and these dots are poplar trees, and the green in between are specially adopted grasses, and the white in the center, these are storage areas for waste, parking lots, and this part is kind of encapsulation in principle, because there are waterproof concrete and special membranes and barriers installed. So this is how it looked like before. On the left, you can see the contaminated material piling and shaping the pile for remediation, then removing contaminated soil from areas where the building was planned to be constructed. So there is no VOCs penetrating through foundations and exceeding the thresholds inside. And, you know, the concrete layer specially constructed with membrane, all properly engineered, shaping the remediation pipe, drilling, because this was quite heavy clay, heavily compacted with very poor physical structure. Therefore, to enable establishment of deep roots, we drilled basically almost 3,000 holes in a grid to fill it with some loamy sand, which is more permeable, and then there can be some drainage into these holes, and then poplar tree work as kind of a pump, moving this up to the rhizosphere. So this is after planting. So this project was implemented rather fast, as you can see. It was financed by the city and with some help of regional EU-funded programs. You can see additional yellow vents. These are perforated pipes going down up to 3-4 meters to provide aerobic condition for the poplar trees to avoid toxicity. This is right after planting. Still, there is no grass. There were some physical degradation problems. We need to integrate more compost between these rows of hybrid poplar. These are the infrastructure. The area was developed, and these are this impermeable barriers made of waterproof concrete. You can already see the hybrid poplar in the background here and there. There are different phases of development. This is the beginning and the end of first season, so they adopted pretty well. And now we have pretty much a kind of nice, well-functioning local landscape with educational path for children to get more familiar with waste recycling, with remediation. So it also serves some educational purposes. So phytotoxicity was a big issue. That's why we decided to drill these holes. I already mentioned this.
Thomas, I'm sorry,
yes?
we've got 1 minute to conclude.
Okay, this is second season, so you can see already very nicely established canopy. And also irrigation is a key because we need this water movement up and down, up and down. The site would not find, and of course, this is a recycled water. And this is last season, really bushy vegetation, so the concept work. There is a protocol for management, and depends on some decisions and financial aspects. I mentioned irrigation is a key, and we expect to have some quantitative outcomes within 5 years to reach some targets. And we already see that the risk is under control. And there's also a monitoring scheme in place, although I'm not very happy with it because there's no adequate financial support beyond implementation. So I hope to offer this site to all of you who are interested and want to collaborate on something exciting and having something beyond experimental pod study. This is, let's say, what I'm going to share. And thank you for your attention. And please make sure that you plan to visit us.
Thank you, Thomas, for that excellent example of practical implementation of remediation. So I do not see any questions at the moment, so we quickly go to our last presenters. So we want to bring the concept of living labs to you. So I would ask Mariela from European Network of Living Labs and Sabina De Lange, representing Living Lab in Dordrecht, who will share the next presentation.
Yeah, let me share my screen 1 second. Okay. Yeah, so hello everybody. It's a great pleasure to be here today. I will present, well, my name is Maria. I'm a junior project manager at IUNG, and I will present the importance of living labs and the particular relevance of living labs and lighthouses for the soil remediation in the context of the soil mission. So before presenting the living lab concept, it's important to contextualize the organization that I'm glad to represent today. So the European Network of Certified Living Labs is funded, was funded in 2006 under the EU presidency of Finland. The goal is to promote the living labs concept, support EU policies, enhance living labs and their sustainability, and enable their implementation at a global level. So the focus is in facilitating knowledge exchange, joint action, and project partnership among members. Despite the name, ENOL has also grown from a Europe focus to an international growing community with more than 160 active living labs present in 5 continents across 38 countries, and historically more than 500 certified living labs. Besides the work that we do with our members, we are also involved in 20 EU-funded projects. And in this case, it's important to mention the Nations already prep soil and soil projects. So what is a soil health living lab? Despite the different approaches and definitions produced over the years, a specific definition is proposed under the soil mission that it's also indicated in the mission soil implementation plan, which defines soil health living labs as user-centered, place-based, and transdisciplinary research and innovation ecosystems, which involve lab managers, scientists, and other relevant partners in systemic research, co-design, testing, monitoring, and evaluation of solutions. This in the context of a real-life setting to improve their effectiveness for soil health and accelerate the adoption. So in line with these aspects of soil health living labs, within ENOL, we identified 6 common elements regardless of the field, which are co-creation, orchestration, multi-stakeholder participation, active user involvement, real-life setting, and multi-method approach. So why a living lab? I won't go into the details. You can read the slide later. You can read this slide later, but living labs offer a real-life environment for creating solutions involving the end users in innovation process. This will allow for a faster innovation cycle that meet the needs of the final users, de-risk the innovation while also improving the societal impact. So, yeah. Sorry. So as you know, we're really proud to see that the living labs are also getting recognized in the EU level. We have now 2 joint working groups between ENOL and the living labs and the European Commission. There's also 22 topics within the 23-24 Horizon Europe work program asked to set up living labs. And living labs are formally cited both as research infrastructure in the European research area, as one of the 5 flagships of the new European innovation agenda. Looking more at the missions and partnership, this recognition is also present. Living labs are recognized as the main co-creation and innovation tool for transition towards healthy soils and agroecology through the EU mission, A Soil Day for Europe, and the Agroecology Partnership, but they're also recognized in the cancer and CITES missions. Moving forward into the mission Soil for Europe, the main aim is to establish 100 living labs, places for real life and on-the-ground experiments and lighthouses by 2030, to lead the transition towards healthy soils in rural and urban areas. The areas identified are divided into the following land use types, which are agricultural living labs, urban living labs, forestry living labs, and industrial living labs. And these common key points are those that guided the support of the Soil Health Living Lab during the mission, which INOS also contributed in. And the preparatory project, these are the preparatory project of Prep Soil and IUNG, and building on these experiences as well as on the well-established knowledge of living lab needs. We're now moving forward to leading the framework partnership of soil that will support the Soil Health Living Labs and lighthouses over the entire duration of the mission. And this is about it for my brief introduction. I will now leave the floor to Sabine, who will explain the Blue Hotspot Living Lab. And it's important to mention that it's not a Soil Health Living Lab, but an example of how a living lab works. Thank you very much.
Hi, yeah, thanks. So as introduced, I will tell you something about the Blue Hotspot or the Blue Hub situated in Dordrecht. It's part of Juverta, which is a veterinary school, or it's a vocational education training center. And this is the content of the presentation. Okay, next slide. So if you want to, so how can we describe the Blue Hub? Here you can find some quotes that state what we are doing and how you can describe us. And as I just mentioned, we are a VAT school, so the depth of our study isn't that much as shown before. What we are focusing on collaborations and research. And yes, we are also a certified living lab by INO. Next. So what you hear, it's a brief overview. So we are situated in the Netherlands. We are the biggest green VAT in Europe, and the location in Dordrecht, it's surrounded by water because we have several rivers around us. Dordrecht itself is also known for its being an island that has to deal with the sea level. We have a lot of peatland and a lot of clay around us, so we have a lot of cows walking around and wetlands and things like that. So we have a lot of soil, and we were also focusing or dealing with the PFAS contamination due to the presence of the Gemoers location in Dordrecht as well. Yep, next slide. So here there's a short movie. Yeah, you can play.
PPS Water Route. We are living and working in a delta full of urban, agricultural, and rural activity. This area faces serious challenges from climate change. Ongoing subsidence damages our buildings, infrastructure, and farmland. Weather extremes such as heavy rains lead to flooding, while long periods of high temperatures cause heat stress in cities, harm crops, and threaten plant and animal habitats. At the same time, the sea level is rising. We need to act fast to protect our delta. The complexity of these challenges requires a new approach. What should we do? The government, entrepreneurs, NGOs, and the entire Dutch education system must work together on projects to achieve shared long-term goals. The issues presented by climate change affect everyone, so cooperation is essential. And in such a complex setting, collaboration must be innovative. This is where we come in. Living Lab PPS Waterroute initiates and facilitates learning networks to find solutions for the climate challenges and creates new education programs for lifetime development. We identify blue-green opportunities that allow collaboration across a variety of sectors. We bring together those working in water, agriculture, smart technology, research, health, infrastructure, and more. Experts from each sector bring their own unique perspective, knowledge, and experience. Their innovations have an impact on a range of projects, from historical geological studies to future-proof agriculture and cities. These projects aim to ensure a safe and prospering region that is able to cope with climate issues. Climate change doesn't stop at the Dutch border. To solve these grand societal issues, we also collaborate at an international level, bringing expertise together in global partnerships. For more information, visit www.pps-waterroute.nl. Be part of this challenge. Join us and let's learn from each other.
Yeah, so you just saw what we are working on. So the different topics that we are working on, and so it's one of the topics. But what we notice, or what we are facing, the problem is more the amount of students that come in. So we have a lot of opportunities and challenges to face, but we don't have the hands and the students, so we can't work on everything, and this restricts us. But the network has been created, and we're still working on it to strengthen that in order to continue with all the topics that you can see in this poster. Next slide. And just to give you a brief overview, like how are we situated, or how does it look like? So the biggest one is the blue hotspot. So we have a hub manager, we have a project lead, and we have what we call it's a practitioner. So we are focusing on different topics, but the biggest challenge still remains the number of students. So that's something that we need to balance sometimes, because it's difficult, because we want to do a lot of things, but we can't promise that we can really execute all these things. So it's also a kind of a struggle. Yeah, so that it's a kind of a brief introduction, like, okay, and maybe also something for you, like if you don't have the people, it's hard to achieve things. So, and I think it's also something that it's also something we all are responsible for. Like, okay, we need to ensure that people are still interested in working on topics related to soil and everything. And yeah, thank you.
Thank you, Marilla and Sabina. That was very important. Thank you for bringing the issue of living labs, how they work, closer to us. So we've finished all the presentations. I think now it is time to ask participants for short presentations.
Yes, I've been contacting some of the participants who were particularly active on our Miro board and our registration form. Again, thank you so much for this attitude, which is absolutely positive and constructive also for the future activities of you guys, but also for us in bridging knowledge to understand what is better to do or what to do about the next calls for the EU soil mission. So first of all, I will forward again the links to continue the networking on the Miro board and also in our matchmaking platform. So if you're interested to dig into more the topics, but also know more people in which you could do some partnerships for the next calls, please use these links. But in the meantime, I will kindly invite some people to do some very short speeches to introduce themselves, their institution, and what they're looking for. So if you are there, please take the floor. I invite Cordelia, which I saw that she wrote also in the chat from a soil association. I don't know if she's still there. I see also some hands raising. So maybe we can give the floor to the ones who are rising. Yeah, I see Oriol Costa.
Okay.
Yes, hello.
I'm Oriol Costa from Ecoregio in Catalonia, in Spain. We are leading a proposal of living lab of agroecology, so quite involved also on regenerative soils, on natural-based solutions. We have experience with hemp and moringa as plants that give very good results on regenerative. So in the chat, I invite you to be collaborators or supporters to this call, and thank you very much.
Thank you so much. And Grega Vogler.
Hello, everyone. Firstly, thank you to the organizer for giving me a minute to present NVIT Limited. I'm a representative of NVIT, which is a research and development micro SME and spin out from University of Ljubljana, Slovenia. So NVIT developed this result technology I posted already in the chat, which is an international patent and groundbreaking remediation solution that enables this closed loop removal of heavy metals and as well metalloids from contaminated soil through zero emission process. So we don't generate any wastewaters while preserving as well the soil as a natural substrate. We are as well involved in EU soil mission project called Aragorn, titled Achieving Remediation and Governing Restoration of Contaminated Soils. And we are at the moment in the process of building a result trailer to showcase our technology throughout Europe. And this will allow us to demonstrate the efficiency and sustainability of our technology to potential customers. So we are eager to participate at Living Labs of Nations Living Labs. And please contact us. And for more news about us, you can check as well the Miro board, which was shared before, or contact us directly. So thank you.
Thank you so much. I don't know if maybe Anna Espinosa wants to say something. Or if not, we can also close the meeting here. Again, I invite you to explore the Miro, take contacts, and contact directly also the participants who are there. You can have access to their information that they kindly gave consent to share among us. And then also consider also registering to the matchmaking platform to continue networking and building relationships in the face of the next calls. I think that's all for me. Gregor, I don't know, you want to close the day?
Yes, thank you. Of course, it is very difficult to conclude in one sentence that bunch of knowledge we could hear today, and also the information collecting during the polls. I will not do this. This is impossible. We just are happy of that interaction that happened in the Miro board and in the chat, sharing contacts. That was the goal of the meeting, to meet people and to know more about increase our common potential for synergy, especially between different domains like research or industry. We know from the poll that this is still needed. So many thanks for the participants for that interaction. I would like also greatly thank our speakers for excellent presentations, and I would like to thank our nations partners for great support during this event, Polimi and also IT Trust. So thank you for this.
Thank you so much.
Thank you and goodbye. Have a good day, everyone.
Thank you.
Have a good day. Thank you.